Hello students, in this video let us see how does a LCD monitor work. So what are actually LCDs? LCDs are nothing, the full form is nothing but liquid crystal display. What are liquid crystals? They are nothing but it's a kind of a mixture which has a property of both liquids and crystals. Crystals, you understand, it's a solid, okay? Liquid is nothing but a liquid. So a mixture that acts both as a solid as well as a liquid, or you can say it as a semi-solid. Okay, so that property, it's not like it will be behaving as a semi-solid all the time. So it depends on the the situation where the liquid or that mixture is um, come liquid comes in contact with the its surroundings. Mainly in our case it is a light. Okay, the polarized light, when it passes through this liquid, it behaves like a solid. Okay, the particles in it behaves like a solid. So the technology called liquid crystal display could be made, okay, because of that property. So liquid crystals can adopt a twisted up structure, and when we apply electricity to them, they straighten out again. This is the key how LCD displays turn pixels on and off. That is, how a display looks like, right? Like we need different kinds of colors, we need different shapes, and that has to be displayed on the screen. So we have seen the working of CRT monitor, how it actually works. There the phosphorus uh, pixels, or the phosphorus, those pixels emit light and you can see the images. So here the technology what is used is different, and the you can say the end product or whatever the output we see, it's almost the similar, right? The screen, whatever the output we see on the screen is similar, but the medium what we see through it is different, right? So what happens, see, liquid crystal, it, since it's a liquid, we need to keep it in a transparent kind of a container. Okay, I'm telling about the technology how it works. And when an electricity is passed, it could be electricity is passed in in the form of a light. Okay, so when it is passed through it, what happens, the particles which usually move according to their will, they align in some direction, that is they straighten out. Okay, so this is the key of this technology. Let us see how it works in the detail. So the polarization property of light is used in the LCD. That is, light gets polarized when there is a the liquid gets polarized when this polarized light is passed through it. Okay, so to what? To switch its colors, that is pixels on and off. That is, sometimes it has to be right, and sometimes this color has to be displayed. And when the video, for example, is moving on, then the different image should be formed on the screen. Then the color, whatever the display is being done, that has to change. That is, it's like on and off of the images, right? So to have that thing to happen, what should be done? This polarization property of light is used. At the back of the screen, there is a bright light that shines outwards the viewer. In front of this, there are a million of pixels, each made up of smaller areas called subpixels that are colored red, green, or blue. That is for the color displays. You need three colors, that is red, green, and blue. Okay, so we'll see how it works. So this is the image. See, this is when anything is not put, that is when light has been not put or the voltage has been not given. Okay, just the display. So what happens, they normally come through this is a liquid crystal, they polarize and they come out. In this, voltage is applied. See, voltage is, when voltage is applied, these crystals which were used, which were being twisted, they straighten up. Okay, then because of that, you get the whatever unpolarized light is there, or whatever the image you need to see, you get to see through this way. Okay, so how this actually looks like, so this is just the how the liquid crystal gets arranged. Okay, so we'll see how it looks like. See, each pixel has a polarizing glass plate filter behind it and another in front of it at 90 degrees. Normally the pixels looks darker. In between the two polarizing filter, there is a tiny twisted pneumatic liquid crystal that can be switched on and off electronically. That is, whatever the display is there, it works with the help of the electricity, right? You should on the power to get anything on the screen. So when it is switched on, it rotates the light passing through it through 90 degrees, effectively not allowing the light to flow through the two polarizing filters and making the pixel look dark. So each pixel is controlled by the separate transistor that can switch it on and off many times each second. So I'll explain it with the diagram. See, this is how it looks like. See, this is the backlight where the unpolarized light is passed. Okay, so this is a glass. You can say it has a glass substrate or a glass. Simply a glass is kept. Okay, and a polarizing film in the sense that actually converts your liquid crystals in the sense it turns the crystals whatever is there in the liquid. So this is where actually the liquid crystal is placed. See, in between this there is a liquid. Okay, when the light passes this polarized light, the light comes through this being polarized, then arranges the liquid in the way it want. Okay, then again it passes through the color filter. Why color filter? Because there are three colors RGB, and your image whatever you're seeing in the output screen, it's always made up of three colors. It may increase or decrease in the percentage. Okay, so for example, if it is the red has to be shown on the screen, what happens? Rest of the two colors are zero. The percentage is zero, only red would be seen, and rest of the things like some yellow or whatever the colors you want, what happens? It becomes a mixture. Okay, so mixture of two or three colors in the various percentages. So once it passes through that, it passes through the color filter also. Then again there is a polarizing film. Okay, then again there is a front glass that you actually can see on your the screen, the glass what you see, and in front of that you get the image that is a color, right? What color you wanted to see, that comes here as a image to be seen. Okay, so there are actually mainly two types like passive matrix display and active matrix display. So what is this? See, passive matrix display has a rows of electrodes on a piece of glass, columns of electrodes on opposing piece of glass. Complex electrical waveform control the voltage differential at the intersection of the electrodes. That is, you can see. So this is here. There is electrode connections. Here also there is electrode connection. Wherever this pass, it forms each a pixel. So for example, let us say if you want to write a C. See, 1, 2, these pixels whatever is there, this gets highlighted. So again till here it gets highlighted. Same thing here and here. Okay, these things get highlighted in here. So totally when you see on the screen what it looks like, it looks like a C till here. Okay, this is how a display is done on the LCD screen. One more thing is the active matrix. See, the passive matrix display whatever we have talked, it was there in the older LCDs. Nowadays this active matrix display is used. So what is the difference? It allows very high resolution. That is, it is not just a single. See, here you can see there are 3 pixels that is highlighted. So there is a small portion where you can see the capacitor, gate, ITO pad, supply line and gate line. So what does it do? It controls each pixel's intensity, whatever it has to be there. So in the previous one we have seen there are no controlling each pixels. Okay, just like whatever the display is, controller gives the information that has to be displayed for each pixel. Here what happens, individually you can control the pixels. Okay, so this is each subpixel. Okay, in each pixel this is a subpixel. So each subpixel is individually controlled by an isolated thin film transistor that we call it as a TFT. Okay, so it allows the electric signal for each subpixel to avoid influencing adjacent elements. That is, see, as I told you, it's a liquid crystal. So whatever the display you're seeing, actually the crystals are being displayed in a manner that it is given a command. But what happens, because of its nearness, it may get affected by the nearby crystals. Whatever the information or the command is given to this crystal may affect this crystal also, but in this technology that is avoided. Okay. And this the TFT is a patterned into the glass layer. This is given, or the it is attached to the glass layer, so that it does not affect the display. There is a liquid crystals. Okay, it does not affect the liquid crystals. Only when it is falling on the glass, there it is altered the intensity. So there are many types in that, which is not included in your syllabus, so we can skip that. So there are some advantages to this. Okay, so why LCD? If you say, compared to your CRT, it is a smaller in size, and it requires less space. You might have seen, right? CRT monitors are big, and whereas LCD comes in very small size. And the power consumption, mainly compared to CRT, LCD is very less power consuming and lighter weight. You have seen the LCD monitors, they are very lightweight. And electromagnetic fields does not affect the LCD, because in LCD it only depends on what they do not emit electromagnetic fields, right? They only have the crystals or the liquid crystals, so it is not affected. And these have longer life compared to CRTs usually. Okay, so this is all about the liquid crystals that you have in your syllabus. Thank you.